Chapter 13, Part 6, Pascal's Principle. Pascal's principle states that changes in pressure at any point in an enclosed fluid at rest are transmitted undiminished to all points in the fluid and act in all directions. A change in the pressure in one part of a fluid is transmitted to other parts. If the pressure of the city water, for example, if the pressure of a city water is increased at the pumping station by 10 units of pressure, the pressure everywhere in the pipes of the connected system will be increased too by a 10 unit of pressure. So Pascal's principle describes how changes in pressures are transmitted in a fluid. Let us take this example. Pascal's principle is employed in a hydraulic press. If we fill a U-shaped tube with water and place pistons at each end, as shown in figure, pressure exerted against the left piston will be transmitted throughout the liquid and against the bottom of the right piston. The pressure the left piston exerts against the water will be exactly equal to the pressure the water exerts against the right pistons if the levels are the same. So let us explain what happened in this U-shape in the next slide. The force exerted on the left pistons increases pressure in the liquid and is transmitted to the right piston. Example: a 1 Newton load on the left pistons will support 50 Newton on the right pistons. How come? In the next few slices, we will try to explain how this will happen. The piston on the left has an area of 1 centimeter square, and the piston of the right has an area 50 times more as great, 50 centimeters square. So when a 1 Newton load on the left piston causes an additional pressure of 1 Newton per square centimeter, the pressure is transmitted throughout the liquid and up against the large piston. The additional pressure of 1 Newton centimeter square per centimeter square is exerted against every square centimeter of the large piston. Accordingly, the total extra force exerted on the large piston and the larger piston is 50 Newton, 50 times more. The larger piston will support a 50 Newton load. This is 50 times the load on the smaller piston. Simply, the pressure in both cases are the same. So small force divided by small area will be equal to the larger force divided by larger area. We can multiply forces with such a device: 1 Newton input, 50 Newtons output. By further increases the area of the larger piston, we can multiply forces to any amount we want. The increase in force is compensated by a decrease in the distance, mind you. So when the small piston is moved downward 10 centimeters, the larger piston, because of the larger area, will be raised only 1/5 of this, or 0.2 centimeters. The input force multiplied by the distance it moves will be equal to the output force multiplied by the distance it moves. As an example, the automobile left in a service station is a straight application of Pascal's principle. A low pressure exerted over a relatively large area will produce a large force which will enable the car to be lifted up. We will explain the details in the next few slices. Pascal principle apply to all fluid, gases, and liquid. The automobile lift is in many surface stations could be explained accordingly. Compressed air exert pressure on the oil in an underground reservoir. The oil transmitted in the closed system. The oil transmitted the pressure to a cylinder which lifted the automobile. Whatever air pressure the compressors supply to the reservoir is transmitted through the oil to the piston that raises the car. Question: as the automobile is being lifted, how does the change in oil level in the reservoir compare with the distance the automobile? Let us think of this example. As the automobile is being lifted, how does the change in the oil level in the reservoir compare with the distance the automobile moves? Answer: the car moves up a greater distance than the oil level drops. Since the area of the piston is smaller than the surface area of the oil in the reservoir. Please note, the surface area of the reservoir does not matter. It contains no piston. Check your understanding by answering this question. What does Pascal principle state?